All right, so it's 10 o'clock, so let's go ahead and get started. Hello, good morning, everyone. I'm Holly Miller, and I'm the new program manager at the Pennsylvania Association of Conservation Districts. I'd first like to say welcome, everyone, and thank you for joining us for the Native Plants and Pollinators training. All of us at PACD would also like to thank the Natural Resource Conservation Service for partnering with us and offering this training. During this training, we hope to present resources that will help ensure the success of ecological conservation and habitat development projects for native wildlife and pollinators. So we do have a couple housekeeping items before we get started. This meeting is being recorded. If you have any questions, please put them in the chat box and we will answer them after the training. Also, when you ask the question, if you could please provide the name of the person that you're asking the question. A reminder, please turn off your video and all attendees should be muted. We are getting a bunch of feedback, so if you are using audio on more than one device, please mute both of them and do not put your phone on hold. So to begin, I would like to introduce PACD to those who are not familiar with us. Our association represents all 66 conservation districts across the Commonwealth. Conservation districts assist landowners and local governments to preserve and protect our natural resources. Many conservation districts also have native plant programs and workshops, so we think this topic will be of interest to our members. As part of PACD's strategic plan, we are creating public service announcements. Our first, which was created in 2020, features native plants and was turned into a 1-minute animated video for sharing. I was hoping that we could play this video for everyone today, but unfortunately we did have some audio issues. So the link for that video, thank you, Peter, the link for that video is in the chat right now. So you can view that. We also have a native plants page on our website at pacd.org under resources, which has the PSA and links to other resources if you scroll down to the bottom, excuse me. So feel free to check out those videos, share those videos, check out those resources. And with that, let's move forward to our first presentation. So first, we have Peter Hoagland and Jim Gillis. Peter Hoagland is the State Forester for the Natural Resource Conservation Service in Pennsylvania. He focuses on providing forestry-related technical guidance for NRCS staff and partners who help private forest landowners with conservation, technical, and financial assistance through federal Farm Bill programs. Jim Gillis is the state biologist for USDA NRCS in Pennsylvania. His responsibilities include CREP, wetlands, and wildlife, including pollinators. Pete, Jim, I will turn it over to you.
Great. Thanks, Holly. And as a reminder to everybody who's either on the phone or calling in from the computer, please mute your lines. You might need to mute both lines if you're on the computer or on the phone. We are still getting quite a bit of feedback. So with that, thanks, Holly. I want to start out by showing some research that highlights the importance of native plants. Obviously, native plants are those that occur naturally in a region in which they evolved. Conservation professionals have long known that native plants play an instrumental role in ecosystems, and recent research is proving that the loss of native plants and the expansion of non-native plants is directly related to insect population declines. This troubling relationship is highlighted in this recent article in Yale Environmental 360. And this in turn can materialize in drastic impacts on the food web, including impacts to wildlife species like birds, because the vast majority of birds rear their young on insects. Other research has focused on how we can address these impacts, and not surprisingly, the main recommendation is to avoid the introduction of non-native plants and utilize native plants. But this is not a one-size-fits-all prescription, and each site is different, and each native plant has different characteristics. So to help with planning, throughout this presentation, we're going to highlight some available resources today. This guide was published by the NRCS Plant Materials Center in Big Flats, New York, and it covers factors to consider when planning and implementing seedings and conservation plantings in the Northeast, which includes Pennsylvania. It emphasizes the use of native species and diversity planting, and it points out the importance of soils, organic matter, and maintaining soil quality as an integral part of all conservation plantings. This guide is divided into sections based on the steps in conducting conservation plantings, starting with planning, selecting plant material, purchasing plant materials, and finally installing the planting. What's particularly important to point out here in relation to this training is the species lists in the appendix of the guidebook, which provides substantial information. This is an example of the tree species lists that are found in the appendix of the NRCS Guide to Conservation Plantings. And these are displayed in a helpful format that can be utilized to compare to the site and soil characteristics that can be accessed through the NRCS Web Soil Survey. The information provided in these lists can aid in the selection of the right plant in the right place. This guide is linked in the Pennsylvania Field Office Technical Guide and is located in Section 1 under Technical References in a subfolder for the Plants Database and Plant Materials Program. Another extremely helpful resource is the NRCS Plants Database, which allows you to narrow the characteristics of specific species. The database contains about 35,000 species, and it includes information like scientific names, common names, standardized symbols, classification characteristics, pictures, distribution maps, native status, and legal status of the plants. Each plant profile page shows county-level distribution maps like this one for pignut hickory, indicating where in Pennsylvania the species is native and where the species is absent or unreported. You can also drill down to the species characteristics, which includes information on plant physiology, growth requirements, reproduction, and uses. A revision of the plants database website is in development right now, and the release is scheduled for April. So this revision is expected to add additional functionality and access on the website through web services. It will turn over data content management control to the NRCS National Plants Data Team, which will help eliminate a backlog of plant data updates that have not been currently accessible on the website. So keep an eye out for the update coming in the next few months. And please keep in mind that both of these resources that I've highlighted so far are good starting points, and the additional information coming from the other presenters today can help you narrow down plant selection for conservation uses. One additional resource that I want to highlight that is extremely helpful and is still in development is the NRCS Ecosystem Dynamics Interpretive Tool, where ecological site descriptions or ESDs are available. The website is the most reliable way to find ESD information, which is available due to a partnership between NRCS, the Jornada Experimental Range, and New Mexico State University. You can follow the link to the ecological site descriptions data catalog on the website. So for these last few slides, I want to give credit to Matt Duval, who helped me put together this information. So through the edit tool, you can use the major land resource area map to narrow down to the MLRA that covers your area of interest geographically. In this example, I've selected the Northern Piedmont MLRA 148, which includes parts of Southeast Pennsylvania. Once your MLRA is selected, you can narrow down to the ecological site that most represents your site. This is where you will notice some limitations in the system so far, especially for Pennsylvania and other eastern states, because many of the ESDs that we have are still in provisional status, which means that they contain enough information to identify the site, but they're not, they may not be mapped yet. So we won't go into depth today on navigating the other portions of the edit website, but I do want to show, and also just to break in, can you all please mute your phones? So I want to show that there are site keys included for most of the MLRAs. that will assist a field professional with determining the correct ESD. The one that I have outlined here in red is from the Northern Piedmont Major Land Resource Area, 148 in Southeast Pennsylvania, and is scheduled to be published to edit soon. It is named Hydric Piedmont Felsic Riparian Zone Swamp Meadow Scrub Forest. It's a pretty involved name, but I point that out because I'll be following this specific ESD through the next couple of slides. So if you notice that the name indicates that the soils are hydric, the parent materials are felsic, metamorphic, and igneous rocks. Its position is within the riparian zone, meaning that it's hydrologically connected to surface water. And its native vegetation communities include wet meadows, wet scrublands, and wet forests. Within an ESD, you can find a wealth of information, including what I'm showing here, which is under the Ecological Dynamics tab, and shows the various states of a potential vegetation community for the particular ecological site. For this example, we've chosen to take one step deeper by looking into the wet meadow state. Here I've selected the wet meadow state and listed here is a crosswalk between other various classification systems that describe the vegetation communities on this site, as well as an extensive list of species commonly found on these sites, including a separate list of exotic species that are also commonly found on this site. And lastly, I want to show this screenshot, not from Pennsylvania, but from the Panhandle of Texas within Web Soil Survey, where they're about 30 years ahead of us in Pennsylvania with ESD development. And that's because of old, what were called range sites that have been around a lot longer than ESDs and were applied a lot more broadly than just range only. Nonetheless, ESDs continue to be developed for Pennsylvania, and we can expect that our ESDs will be mapped and correlated to the soil map units and reported through Web Soil Survey. The ecological site IDs and the names that you see listed in the ecological sites column here are actually links to the descriptions in the edit database. So this does a lot to streamline access for planners. And this will eventually be done for the Pennsylvania ESDs. And with that, I am going to turn it over to Jim Gillis, who is the NRCS state biologist.
Okay, thank you, Peter. Could you also page through my slides here so that we don't have to try to bounce control back and forth for the presentation?
Will do.
Okay, thank you. Good morning, everybody. I am Jim Gillis. I'm the state biologist here in Pennsylvania, and I'm going to talk to you very, very briefly this morning about specific pollinator mixes that have been developed in Pennsylvania. One thing that a lot of folks realize already is that there is a pollinator mix for Pennsylvania developed by NRCS in conjunction with the Xerces Society, and it's been around for quite a while, and it is sort of the baseline or basic pollinator mix that we use. It does contain a variety of native perennial forbs. The major intent of this mix is to provide multiple blooms throughout all three of the growing seasons. And I know it's strange to hear somebody say there's 3 growing seasons, but in terms of native forbs, that is correct, because there are plants that are growing and blooming in the spring, summer, and fall. For example, what we would consider late summer and fall wildflowers are actually some of the most common or most recognized among the wildflowers, such as purple coneflower, some of the daisies and some of the asters that we commonly see, and goldenrod that we commonly see as roadside flowers. This basic mix is designed to be beneficial for a wide range of native pollinators. It is not specific to any particular group or subgroup, aside from a focus on native pollinators. So it does cover bees, butterflies, moths, even some of the beneficial wasps and things like that. It does not necessarily benefit European honeybees or domesticated bees quite as much, and we did that deliberately, simply because in those places where people are farming with domesticated honeybees, they tend to have a lot of clover in their landscape because clover is actually a preferred source for the European honeybee. The other thing about the NRCS basic pollinator mix is that it's based on a lot of different aspects of the plants that are included in it. we try to include plant species that are commercially available, reliably commercially available, less expensive, easier to establish, and persistent in the landscape. Now, with all of those things said, I have to point out that all four of those statements are really, really relative statements. You know, when I say that they're commercially available, it would probably be more accurate to say that they're commercially available during parts of the year and in relatively moderate amounts. You know, the demand for wildflower seed has grown in the last few years in particular, and as a result, supply is growing with it. But there are species out there that we would love to include in these mixes that simply aren't commercially available. Or if they are commercially available, you know, they cost $600 or $700 a pound because of the difficulty in collecting and cleaning and, you know, producing the seed. So, you know, the mix is not what some people would consider sort of the ideal or the best possible mix, but in reality it's the best mix that we can routinely and realistically provide on a landscape scale to achieve the benefits that we're looking for. Next slide, Peter. More recently, actually just within the last year or so, with a considerable amount of assistance from the U.S. Fish and Wildlife Service, we've identified 9 additional priority pollinator species here in Pennsylvania, and I list them here. Some of them are, you know, pretty readily recognizable, like the monarch butterfly, and you know, the regal fritillary's gotten some press here in Pennsylvania because of its presence at Fort Indian Town Gap. The American bumblebee and things like that. You know, some of them are fairly well known. Others are not known or very unknown. For example, the ostrich fern borer moth or the columbine dusky wing. But there's going to be presentations on these and some more additional information on these later on, so I'm not going to cover this in any detail. But what I want to point out is that of these 9 that are listed, not all of them occur in every county throughout Pennsylvania. The monarch butterfly, yes, we can see those just about anywhere. Same with the American bumblebee. Any of these other ones don't occur everywhere. So as a result, Peter, next slide, please. What NRCS did, we developed county-specific amendments to our basic pollinator mix. And I did this for every county in Pennsylvania. And each of those county-specific worksheets will help planners identify which of those priority pollinators might benefit from the work that's being done based on the landscapes that you're working in. And I listed a couple examples here. You know, are you in farmland? Are you in a forest edge or opening? Are you in the riparian zone? Are you in a mature forest? Because where you're planting will affect, without a doubt, which pollinator species might occur there. For example, the picture on the right here shows that forest edge. The species of pollinators that occur here are very, very different from the species that might occur out in the middle of active farmland, for example. These county-specific lists for the pollinator priority species can be found in the Field Office Tech Guide. I listed the location of it here. The thing to keep in mind is that they are found in the Wildlife Habitat Planting, or 420, practice standard, which is, for many of you, a new practice standard. But all 60-some pollinator mixes worksheets can be found there. All you have to do, you can see there's a slightly different blue shade where it says County Name 2021. You literally just search for the name of the county that you're working in or planning in, and that would be the worksheet that you choose. So obviously, if you're planning in Adams County, you choose Adams 2021. If you're planning in Center County, you choose Center 2021. There are also pre-written instructions on how to use these worksheets at that same location, which are very, very helpful. So I would say, you know, the first thing you want to do is look at the instructions. Then the next thing you would want to do would be pull up the actual worksheet for your specific county. Next slide, please. So here's an example of what the pollinator worksheets would look like. This example was pulled from Center County simply because Center County had a nice variety of fairly common pollinator species, but then also quite a few of the priority pollinator species. And it's really a very simple 3-step process for this. Here, if you could hit the next arrow, please. So the first and really one of the only things that you can do on this sheet is to put an X in these yellow shaded boxes beside each type of landscape. That's really the only box that you can enter information to in the worksheets. And as soon as you enter an X in there, next button, Peter. As soon as you enter an X into one of these boxes, these gray and white lists underneath will auto-populate, and it will tell you that in this county, in that particular landscape, these are the priority pollinators that might occur. And then it will also tell you whether or not the basic pollinator mix is enough, if it's adequate as is, or if you need to add something else. And then Peter, one more time to advance it, please. And at the bottom of each of the worksheets, you'll see these tabs that list each one of the priority pollinators. So then you can use the list that's been generated to say, okay, I have monarch butterfly, I have American bumblebee, and you select the appropriate tab at the bottom of the sheet. Next slide, Peter. And one more time. So in this particular example, we had a hit for frosted elfin. So I selected the frosted elfin tab, and this is the page that comes up. Peter, if you could do 6, and I apologize for this, but if you could do 6 right arrows in sequence, that would be great. This format didn't cooperate the way I'd hoped that it would. But each of these tabs and each of the information sheets that come with them has a very standardized format. Each of the sheets will give you a description of the pollinator species in general, sort of a life history of, what they need, how they use the plants in question, things like that. It will give you specific planting information about how much of the plant is needed, what rate it can be planted at, things like that. And then the other thing that's very helpful is that it will provide photos of the plants in question. I didn't provide photos of the pollinators themselves because those are relatively easy to find. And most people are excited about the pollinators. They really don't know what the plants pollinators rely on look like. And you won't have the pollinator if you don't have the plant. In this case, I erred on the side of the plant photos so the people have an idea of what they'll be planting out there and what they can expect to see. But this information, the format will be the same for all 9 of the pollinators priority species, but the information contained on each sheet will vary by pollinator species. Next slide, please. And with that, I'm going to end with a summary to go back and say that, yes, we did develop county-specific amendments to that basic pollinator mix, one for each county in Pennsylvania. They can be found at that location in the field office tech guides. And if anyone has any questions that aren't answered by the instruction sheet, please feel free to send it to me at the email address here, or you can give me a call, and I will be happy to help. One last clarification that I want to point out is that in all cases, the basic pollinator mix is a very, very good start. And we always want to recommend that folks use that. If possible, try to include the other species that would benefit the priority pollinators, but in some cases, those plants aren't going to be as available yet. For example, eastern red columbine, which is required by the columbine dusky wing, is not commercially available in any real quantities. So as a result, you may not always be able to include that in the mix. It's always advisable to try to include these priority plants, but if they're not available, please at least move forward with the basic pollinator mix for that area, and we can potentially add the additional species of plants later on. And with that, I'm done. Thanks to everybody for dialing in this morning, and if you have questions, please forward them to me at that email address listed on the screen. Thanks.
Thank you so much, Pete and Jim. I just want to remind everyone, if you do have questions, again, please put them into the chat box, and hopefully we can get to a couple at the end of the training. And also, if you are just joining us now, please mute your mics. If you are using 2 devices, You'll want to make sure that you have them both muted. So our next presenter is Greg Zarnecki. As DCNR's Director of Applied Climate Science, Greg oversees climate change adaptation for state parks and state forests and ensures that climate change is integrated into all of the department's operations and policies. Greg?
Great, thank you. Can you hear me?
I can hear you.
Okay, great. And can you see the PowerPoints?
Yep, I can see them.
Okay, great. Thank you very much, and thanks for inviting me today. I'm going to be talking a little bit about some of the work we've done at DCNR in terms of looking at climate change impacts and also looking at some of the things we can do to adapt to climate change. So I'm going to focus today really on forests and trees. So I thought the first thing that we should do is really talk a little bit about what impacts are we seeing from climate change and what are some of the projections, because that kind of informs our decision as to the kind of trees that we're going to be planting. So let's start off by talking about temperatures. And this graphic here shows you the increase in annual temperatures across the lower 48 states and also Alaska and Hawaii. And so the way you interpret this is that areas that are red are seeing significantly warmer temperatures than average. At the top is kind of an overall annual look at that. You can see most of the country is red. And at the bottom, it breaks it out into winter and summer temperatures. And you can see we're really seeing the most significant warming here in Pennsylvania and across the US in winter temperatures. So far, we've seen about a 1.8 degree Fahrenheit increase in temperature. So what can we look forward to? Well, let me orient you on this map here, or this graphic a little bit. The top two maps are from the middle of the century, and the bottom two are from the end of the century. And if you look on the left-hand side, it says lower scenario, and on the right-hand side, it says higher scenario. So you can kind of think of the lower scenario as the best case. This is what we can expect if we get our emissions under control very rapidly. The worst case scenario that you see on the right is if we keep doing what we're doing now. So if you see, take a look at this, you'll see that even under the best case scenario, by the end of the century, we're going to see probably a 4 to 5 degree temperature increase. In other words, a 2 to 3 times increase over what we've seen already. The worst case scenario, we're going to see parts of the state that are going to see 8 degrees plus increase in temperature. So it's a little hard to wrap your head around exactly what this means. It's kind of nebulous. So let's kind of put it in more concrete terms. There's this website called 1001 Blistering Future Summers, where you can plug in the city or town that you live in, and it's going to show you what temperatures are going to feel like at the end of the century under this scenario where we can continue on the path we're on right now. So I chose State College. And in State College, the average summer temperature is about 80 degrees. By the end of the century, the temperature is going to be much more similar to Kissimmee, Florida, over 91 degree average summer temperature. So think about the plants and the trees that you look at planting here now and compare that to what you see growing in Kissimmee, Florida. You can see there's a really significant difference, which is why we really want to kind of think about what it is we're going to be planting. Now, in addition to increases in temperature, we're seeing really significant changes in precipitation. And here I'm going to talk about rainfall. And so the map that you see in the upper left there is a map that looks at the percent increase in very heavy rain events. And you can see the northeast part of the US sees the highest increase, 55%. If we were to drill down even further and look at just Pennsylvania, we've seen over a 70% increase in these really heavy rain events. And so the photo from the lower left is from our Loyalsock State Forest, where in a period of just a few years, we had 5 different 500-year flooding events. And those are events that would only normally occur every 500 years. And so we're dealing with a lot of infrastructure issues at DCNR, but also we're seeing a lot of flooding and forest damage. In the photo at the upper right, that's the Appalachian Trail down in Caledonia State Park that's washed out at the same place 4 or 5 times now in the past few years. We're also seeing a really unusual kind of flash flooding events. And so the photo at the lower right is Route 283 between Harrisburg and Lancaster from a couple of summers ago when a thunderstorm developed. And because of the rapidly warming Arctic, we're seeing changes in the jet stream. And so one of the results of that is that we see storms form, dump huge amounts of rain because warmer air holds more water, but the storms don't move. They just kind of sit in place. And this is an example of that. So we're seeing a lot of this as well. In terms of growing season.
I'm sorry to interrupt. Would you be able to make your presentation a little larger for everyone? I don't know if it's in the presentation mode.
Okay. So on my screen, it's showing full screen. I'm not sure how to do that. Is that any difference?
It's still showing up pretty small.
All right. Does anybody have any suggestions as how we can change that?
Greg, if you go under, click on display settings, and click on that drop down, you might be able to change it to full screen. We're seeing the notes view.
All right. Bear with me. I've got too many screens open here. All right, where are the display settings again?
It looks like it's right at the top of your screen, Greg. Someone also suggested that if you have double monitors, sometimes it shows the presenter mode when you have two. So when you're sharing, just make sure that you share the right monitor.
Okay. Sorry, folks, I'm having a hard time figuring this out here. Is that any better? Is there any improvement there?
Oh, yeah, that looks good.
Okay.
That looks good.
My apologies for having had that happen before. Okay. Sorry about that, folks. Okay. So what I was saying is we're starting to see changes in the growing season as well. Here in the Northeast US, about 10 days per year, which is, a great thing if you're, planting for pollinators or you have a vegetable garden. But what we're also seeing is a result of that change in the growing season, we're seeing a lot more frost damage in our state forests. And so that's what you're seeing at the lower right there, is frost damage, because we're getting a lot of these warm days that come late in the winter, early spring, and the trees will bud, and then you'll get a frost. It kills the buds. It doesn't kill the trees, but what you have happening is that, it eliminates the production of mast or fruit for that season, but also lets a lot more sunlight into the forest floor, and it changes the hydrology of the forest floor, and you get different undergrowth as well. We're also seeing, and it's ironic that I should be talking about this because as I look out my window, it's snowing pretty hard, but we're seeing a lot of reduced snow cover across actually most of the country. And so the graphic on your left shows you changes in snow cover. The orange dots represent areas where there's less snow and more rain. Blue dots are the opposite. And so if you take a look at the graph at the right, it shows you how we're seeing already significant reductions in persistent snow cover in the state. Now, this year is an exception. And actually, it's going to vary from year to year. But for the most part, we're seeing a lot less snow cover during the winter, which has impacts on moisture levels, has impacts on winter recreation, and things like that. The other thing I'll say is that almost all invasive species and pests do better under a climate change scenario. I have just two here that I'll briefly mention. On the left are photos of kudzu which, as you probably have heard, is kind of referred to as the vine that ate the South. It's an Asian plant that is primarily thought of as being a southern species, but it has moved into Pennsylvania. And these photos show the plant growing, flowering, and also producing seed within the city of Lebanon is where I took these photos. But also the hemlock woolly adelgid, which is a pest on our state tree, has been doing better as well because they are controlled by cold temperatures. But as our temperatures during the winter have warmed, they've been moving to the north and to the west in the state, so they're more of an issue. So how are species going to respond to all these changes? There's three possibilities. One is that they're going to adapt. And here's a couple examples of species that are going to be okay. White-tailed deer shouldn't surprise anybody. But the timber rattlesnake looks like it's going to do pretty well under climate change scenario as well. We've done climate change vulnerability analyses for about 100 species. And a little later on, I'll show you where you can access some of that information. So adaptation is one option. Another is that if the conditions aren't right, you're going to kind of get up and move. And so mobile species like birds have a better chance of basically outrunning climate change, if you will. But there's still the caveat that they have to have a place to go. And when they arrive there, there has to be sufficient food and water and nesting locations. And then the third thing that can happen is that you're just not going to be able to adapt. You're not going to be able to move, and you're going to just kind of wink out. And here are two species in Pennsylvania that are really at risk, and it's the bog turtle and the spadefoot toad. Both species that have very specific habitat requirements, and as you can imagine, have very limited ability to move. Now, I have focused here on animals, and I know what we're here to talk about today really is more talking about plants. But these three options hold for plants as well. Many of our tree species and our plant species are going to adapt. Others are going to begin migrating to the north or higher elevations, and then some are not going to do well. One example is sugar maple. Looks like it probably won't do well under future climate conditions. So let me give you just one example here of a tree species that, rather than moving out of the state, is actually probably going to be moving into the state. And so this is Virginia pine. On the left-hand side, you can see the current distribution. And on the right-hand side, you see two projections. One for the low emissions or the best case scenario, another for high emissions or the worst case scenario. So you can see that Virginia pine potentially could become a significant component of our forest here in Pennsylvania. Now, these maps come from the U.S. Forest Service's Climate Change Tree Atlas. So that's the first kind of resource that I'm going to mention to you that you may want to look into. We worked with the Forest Service and the Northern Institute of Applied Climate Science to take and apply this tree atlas to Pennsylvania. So I'm going to show you how we did that. Now, the information that follows from here on comes out of our climate change adaptation and mitigation plan, which is available on our website, and the web address is down below. And you can access a lot of information in there. It covers all the work that we're going to be doing for state parks and state forests. So it's everything from infrastructure to recommendations for trees to plant to recreation. We have over 120 different recommendations that you might find of use either for projects related to pollinator planting or to other things as well. So just as kind of give you a flavor for it, from the conservation end of things, there's a number of things that we include in the plan. Among them is looking at how do we connect habitats so species have the ability to move to the north and to higher elevations as conditions change. Climate has changed continuously since the planet began. And in the past, when we had significant climate change issues, like the ice ages, species kind of ebbed and flowed across the landscape as conditions change. But it's a lot more difficult now because now, we have energy infrastructure, we have cities and towns and roads. We've really fragmented things. So a big part of what we're doing is trying to identify those places that will be important to make up those highways for species to move. But what I want to focus on next is what kind of trees will be better adapted to future conditions, because I think that's probably what you're most interested in. And so I know the slide is a little hard to see, but I'll try to kind of orient you here. What we did is we worked with the Forest Service and asked them to break the state up into physiographic provinces and look at pretty much all the trees that grow in those areas and do downscaled modeling to tell us which trees will do well, which potentially won't do well, and if there are any new ones that are going to move in. So the example I have here for you is the Ridge Valley. And so each of these is a kind of a 2-page fact sheet, and you can download these from the website you see at the bottom there, forestadaptation.org. The first page shows you kind of a brief list of species that are likely to decrease, that may increase, that may not change, and various things in between. On the right-hand side, and I'll use my cursor here, is a list of trees, and you see there's 2 columns that have colored symbols. Those are 2 different climate models. And when you see kind of an orange triangle, that means that species probably will not do as well. There will not be as much suitable habitat. Green means it will do better, and yellow means it'll probably stay the same. And then in some of the areas, and there's only 1 species in this case, you'll see blue asterisks. These are for species that don't occur here now, but are likely to move in. And in the case of the Ridge Valley, sourwood is likely to be a new species for us. So this might be one thing you might want to kind of consult when you look at different types of trees. Now, keep in mind that models are, all kind of, they all have faults. So it's kind of a best case scenario. That's why we use 2 models here, so you can kind of compare the results. This would be a great tool that you can use when deciding what trees to plant. It shouldn't be the only consideration, however. You still have to take into account things like microclimates, aspect and slope, soils, things like that. But still, this could be a useful tool for you to use. Another thing that we have in the plan is projections of future heat zones and future hardiness zones. So the heat zones are maps that look at the number of days that will exceed 86 degrees. And so on the left-hand graphic, you see 2 columns, the low and the high, worst case, best case scenario. And you can compare current conditions to what it's going to look like in the future. So under future heat zones, you can see that much of the state is going to go to having anywhere from 90 to 120 days a year where it's going to be above 86. So that's something to keep in mind when you choose plant species. The hardiness zones, which you see on the right, looks at minimum annual temperatures, and you can see that we expect to see really significant changes in those minimal annual temperatures during the winter time. So under the worst case scenario, in many places, the minimum temperature we might see across the state is going to be 20 to 25 degrees. So another thing you might want to kind of consult. Now, if you're working on projects in urban areas, the Climate Change Tree Atlas has also done specific analyses for a number of cities within Pennsylvania. And the cities are listed here, anywhere from Erie up in the northwest to Philadelphia down in the southeast. And it looks at potentially how those trees are going to do under future climate conditions and how adaptable they are. This is just a small snippet of the data that's available, and a small snippet of the number of trees. So if you take a look at this, for example, it shows that sweet birch will see large declines within, this is from Harrisburg, I should know, this is the Harrisburg model here. So that might be another thing that you might find useful. And then I'm just going to wrap up here. I mentioned earlier that we've done analyses of different species and how they're going to survive under climate change scenarios. And so this is just kind of a screen capture from our Natural Heritage website, and you can see the website down below there. And I realize it's showing animals right here, but actually most of the list are plants. It includes a number of trees, shrubs, and various other plants. So it's another source you can go to. And what you'll find is there's a column that says CCVI score. So it's the Climate Change Vulnerability Index. And it can be anywhere from extremely vulnerable to presumed stable, or they could increase. If you see a plant or a tree you're interested in, you click on that, and it will actually explain to you the various factors that went into making that determination. So with that, I will stop there. Thank you. I apologize for my screen being too small, but hopefully you were able to glean some useful information.
Thank you, Greg, for a wonderful presentation. If you have any questions for Greg or any other presenters, I did put contact information in the chat, so also feel free to reach out to any of us as well. Next up, we have John Tauscher. John is the Private Lands Section Chief for the Pennsylvania Game Commission, where he coordinates the agency's private lands programs, which include improving hunting access and wildlife habitats on privately owned lands. Prior to this position, John conducted environmental assessments on proposed energy projects, oversaw the PA Game Commission's wind energy program, and worked with grasslands and grassland wildlife at Fort Indiantown Gap. John?
All right, thank you. Can everybody hear me okay? Hello?
I can hear you, John.
Oh, okay, great. Thank you for the introduction. My name is John Tauscher. I'm with the Pennsylvania Game Commission. Today I'm going to talk about two different things. One's going to be native trees and the history of the Game Commission. And then the second one, I'm going to talk about some conservation tools that the Game Commission and some of its partners have developed that could help you as you're doing some planning in your districts. To start off, we got the obligatory history of the Game Commission. So our purpose is to manage and protect wildlife and their habitats while promoting hunting and trapping for current and future generations. When we were first established in 1895, the biggest thing that our concern was the decreasing populations of game animals. So one of our primary focuses early on in our history was focusing on season and bag limits. We did recognize the value of wildlife habitat, and very early with landowners to put plantings and habitats on private lands, and most of that revolved around small game populations and small game habitats. We did vigorously promote plantings for various wildlife. A lot of that is still present on the landscape today. Unfortunately, things we're noted for is our promotion of multiflora rose and autumn olive. After some of the incidents we've had with that and the fact that we're still fighting that on our own properties, we quickly realized the value of native plants. So we focus on native trees. Obviously, it's the same for all types of native plants. So they're adapted to the water that in that particular area. So they're adapted to grow with the weather patterns, such as the rain. They're adapted to grow well in the soils that are present. And they're adapted to handle any kind of snow that comes in their local region. Wildlife obviously depend on them. They depend on them for food, and many different species evolved over time, specifically to certain trees. A lot of insects are similar to that, where they depend on various tree species for certain parts of their life cycle. Native trees also reduce unwanted competition. One of the big things about non-native and invasive species is they can outcompete trees, which has an impact on wildlife. And then finally, by focusing on native trees, we reduce the risk of introducing pests. So a lot of times when you import native, non-native species, you run the risk of bringing in pests that can impact our native plants in the long run. What the agency did to promote plantings and stuff is we created the Howard Nursery, which first began producing seedlings in 1950. The primary purpose of that nursery was to provide stock for game lands. It evolved to provide planting stock for hunter access cooperators. We provide seedlings for the seedlings in the school program. And over the last 15 years, anything that we have left over after that, we do offer to the public for sale. We provide between 2 and 8 million seedlings for those purposes. Primarily, our main focus on native trees and shrubs. However, I got to be honest and say that some of the trees and shrubs we do provide are non-native, but they have exceptional wildlife value. Some of that might be, apple, and then also like Colorado blue spruce and some plants like that. This year, looking at some of the pollinator species that we have, this year, over 100,000 pollinator-friendly trees and shrubs are going out to 1,700 landowners that are enrolled in our Hunter Access Cooperator. Some of these species include American mountain ash, crabapple, wild plum, dogwood species, nine bark, and this isn't all the species that we offered. These are the species that are more commonly associated with pollinators because they have nice flowers for pollinators. So this one's see the forest for the bees. Like forests aren't typically associated with pollinators. Most deciduous, or a lot of deciduous trees in the eastern forest are wind pollinated, so they don't rely on pollinators to reproduce. As more research comes to light, we're learning a lot more about the importance of for pollinators. At the most recent forest landowner conference, there were two particular presentations that really stuck out. The first one was by Catherine Mead and some of her counterparts coming out of Cornell University. Basically, they looked at bee use at different stratums of the forest. So they looked at understory, mid-story, and the canopy. What they found was that throughout early spring, at each one of these stratums, there was a lot of diversity, and there was a lot of use at all three stratums. However, as the canopy started closing, the bee activity and the bee diversity at the lower understory and midstory decreased. However, the use at the canopy didn't decrease even after leaf out. Another interesting fact is at the canopy level, the vast majority of the use is by female bees. So they're looking into doing more research, but one of the things they hypothesized about that was the bees were using the wind-blown pollen that normally covers all of our cars and everything else. So I'm looking forward to some more research coming out of that based on some of their findings. The next one, Indiana University. They've been doing work for a long time on golden-winged warblers and some woodcock work throughout the state getting on the ground. So they assessed pollinator use at some of these plots that were managed. So basically they had some forestry activities, moved the older forest to create young forest. They found that there's a lot of increased pollinator abundance after the forest harvest, which is kind of makes sense because after you cut the trees, there's flush of flowers and grasses and stuff like that. Also over time, so looking at it about 6 years later, there was a significant of the abundance of pollinators that they found. Interestingly, they found over 200 flowering plants observed between May and September in these plots throughout the years. And I want to make note that that was just flowering plants. There could be a lot more that they didn't identify if they did not see them in bloom. I know Jeff Larkin, who oversees this project, is also extending this to Michigan and Minnesota, or Wisconsin and Minnesota, I believe. And they're specifically looking at monarch use at some of the young forest projects that they have focused on woodcock and grouse, I believe. So the big thing coming out of these two studies that really hit us was forests that have a mixed age class to support a wide, diverse pollinator communities. So typically what you think of as habitat being, you know, your grasslands and meadows that have lots of flowering plants. While they're awesome for pollinators, forest habitat also plays an important. So I didn't want to dwell too much on that, the native trees, because I knew some of the other presentations. So I would like to focus. Sorry, can we please make sure that all the mics are muted? All right, thank you. The next topic I want to cover is some conservation tools that we've been working with. The first one that I think is the Wildlife Action Plan Conservation Opportunity Area tool. So again, we manage wildlife, specifically birds and mammals, while promoting hunting and trapping opportunities for future generations. Well, if you look at all the wildlife species, the birds and mammals we have, more than 80% of those are not game species. So with the historical way that we manage our wildlife, we're missing out on a huge chunk of wildlife that's out there that isn't typically what people think of when they think of the game. So the state wildlife action plans, they exist for every state and territory of the U.S. Basically, they're plans for 10-year time span. They're comprehensive, they're non-regulatory blueprint for management. They are directed specifically towards at-risk species. And then the proactive, cost-effective conservation to prevent species from becoming endangered. And the state wildlife action plans in Pennsylvania were a huge undertaking. They have, they were developed by the Fish and Boat Commission. There's been two so far, 2005 to 2015. And the current one goes from 2015 to 2025. These are huge documents that have an extraordinary amount of useful information in. So the electronic document is about 2,000 pages. If you printed out hard copies of everything, it'd be about 15 pounds of stuff. Like I say, there's so much useful information in it, but the problem with most of that stuff in 2,000 pages, it's hard to find exactly what you're looking for in an efficient manner. So what the Game Commission, Fish and Boat Commission looked at was trying to get that data into a user-friendly device. So they came up with this conservation opportunity area tool. Again, it revolutionizes the plans for end users so they can actually understand what they're looking at and find stuff easy. It digests a massive amount of information into a usable format. It enhances the relevancy to the user. It provides versatile implementations of the conservation actions. And it does provide a dynamic database that is regularly updated with new species information. So everything that goes conservation opportunity area tool is built on data that we have. So this can always be updated, and in fact would support all people updating. It does cover vertebrates, so it covers like butterflies and pollinators. So if you are interested and you monitor stuff, you can go to eBird, iNaturalist, PARS, and a bunch of others, and actually input records if you find stuff. The more records we have in the database, the more accurate and useful the program will be. If any of you are familiar with the PNDI or the new PACE tool, it's got the same and feel for it. So I'm going to go over a couple of slides of what it looks like. So as you're developing this, you go in, you create a map, you can draw a polygon of what you're looking at, similar to the PNDI system. You can pick various layers that you look at. From there, you can run the spits out something similar to a PNDI or PACE report. So this would be the first page, gives you the name of what you're calling it, when you're running it, the area, a bunch of different things there. But it also, the key part here is it picks out the species of greatest conservation need based on the model and the data available in the database. It provides the species, but then it also provides where they are. So looking in Kestrel, for this particular spot, it'd be breeding season when we're interested in the most probable time you'd see it. It takes agricultural habitats, and then it gives you specific habitat requirements for those various species that are likely to be on the property. The next thing that's really important, it actually gives you conservation actions. So here they're break down into like high, moderate, and low actions. So here you can see down here different actions you can take that'll have a high impact on those specific species. So if we look here at the grasshopper sparrow and beard sparrow, we know that we can do a lot of good in vegetation management. So creating or maintaining grassland habitat, particular warm season grass. Or if we look up here at the wood thrush, you know, we can do land use planning, so cluster any kind of development and utilities into one area to provide for less fragmentation. The next useful aspect is if you do want more information, provide you contacts of where you are. So I'm just going to use the Game Commission as an example here. It tells us that we're in the southeast region, and then it also kicks out and tells who your contact should be for the region. So the southeast, this would be Dan Mummer. It also gives you contacts for U.S. Fish and Wildlife Service, and Boat, and other agencies that'll have more information. Again, this is a collaboration between Fish and Boat, Game Commission, NatureServe, DCNR, and Western Pennsylvania Conservancy helped create this because it's similar to the PACE system. And it was supported by state wildlife grants. So thank you to the U.S. Fish and Wildlife Service. Do you want more information, because this is a huge program, you can definitely feel free to contact Kathy Hafner or Diana Day with the Pennsylvania Fish and Game Commission. I know they are more than willing and excited to let more people know about this program. So they would be more than willing to provide detailed training on all aspects of this program. The next tool I want to talk about is the Grouse Priority Area Siting Tool, or GPAST. So over the last week, populations for young forest species have been declining. And it's not just the last few years, it's been for decades. And most of that is because the young forest habitat in the landscape is declining. This isn't unique to Pennsylvania, and one of the next graphs I'll show you, it's throughout all of the Northeast and the grouse's range. However, recently, West Nile virus rapidly accelerates the decline of these grouse. So here's the graph that I want to show you. Again, we're not in this alone. As a matter of fact, compared to some of our other counterparts, we're doing better. If you look at Kentucky, over the last 3 years, there's been a 77% decrease in grouse during their flushing surveys. So this is pretty complicated, but I'll break this down for you, make it as simple as I can. So the line going from left to right is grouse abundance from year to year, going back to the 80s. The red bars are years when we had high West Nile virus activity. So we compared two different well-monitored grouse populations, one in the northwest and one in the southwest. The takeaway point here is populations in the northwest where they have better habitat are doing better than in the west region. So grouse do better in good habitat. The solution that we found with the Pennsylvania Game Commission they do is target habitat management to areas where it's going to be the most benefit for grouse. So most of the next coming slides are going to be focused we're doing on game lands, but it is definitely widely applicable to the general public in the Pennsylvania landscape. So again, focus where the disease risk is low and there's the greatest possible response by grouse. So what do I mean by disease risk low? So we want to look at elevation. We know above 2,200 feet, the risk of West Nile virus is low. At about 1,900 feet, there's still a risk, but it's moderate. And then there's a little bit higher risk of West Nile at 1,600, but it's still doable. Anything below that's not going to rank real well, and you're going to have a lot more potential risk for West Nile virus. Other things we're looking at is slope. We know that on slopes, water doesn't really pool up quite as much. You don't get stagnant ponds with mosquitoes breeding. And then we're also looking for well-drained soils for similar reasons. So we want a grouse response to be high. So we want to have the greatest possible response from grouse when we do work. So looking at how we're going to do that, we want to focus near source populations, and we want to look at a landscape scale. So what do I mean by source populations? Grouse are not migratory birds. They actually only distribute a couple miles from established populations. So if we want to target anything specific to grouse, we want to focus within 2 miles where we know grouse currently exist.
SEC
as far we basically expanded this out to again, we're looking at elevation and all that. We came up with 3 priority levels. You got your good, your better, and your best. So looking at the map, we look at where populations most secure and where do populations need immediate attention. Zoom in, see how this can actually work. As you zoom in where you're looking, you can target which areas that you're doing the work will have the biggest and greatest impact on grouse.
We're talking for the plan that they already have, the Amendment A, right?
All right, guys. Can you mute yourselves?
Yeah, that if I'm understanding it correctly, that's still Culp Family Dairy LLC. But then we need the site name.
All right, press on.
So
excuse me, everybody. Can Carl please mute? You're on a different line, and we're overhearing your conversation. We don't need to.
All right, thanks, Peter. All right, so again, let's look at a case study that we have on Plans 176. So this is Scotia Barrens. It's right outside of State College. We have actually over 25 years of habitat management for grouse, and we have a long history of monitoring thanks to the help of Penn State University. Grouse detections. If we look back 1994, we had super grouse there. It was excellent habitat, and we were actually competing with Wisconsin for grouse abundance.
But I had family dairy and farm one as potentials.
Surveys in the spring of 2019, after years of intense management, yielded in 8 miles of survey. Looking at October of 2019, we found 0 birds in 13 miles. And that's despite focusing on this area for young forest for golden wing warbler, various other young forests. I mean, there was an excessive amount of habitat for young forest on Scotia Barrens, and we are not seeing any kind of positive response from grouse because of it. However, if we zoom out and use some of the we have with the GPAS tool, you can look, if we focus that area slightly to the west on one of our other state game lands, we know we have viable source populations, we have low risk of mosquitoes and West Nile virus, and then we also have, well-drained soils and stuff on that ridge. So one of the things the Game Commission is looking at doing is using that data to more focus where, if we're going to focus on grouse habitat, put it where we know we'll get the absolute best response based on the conditions that we're working with. So here's another case study on the Loyalsock State Forest. So Nettle Ridge. They've been planning a couple smaller forest treatments throughout their thing. Basically, we took those plots, overlaid it on the GPAS tool, and we noticed that they're in good habitat, surrounded by okay habitat, surrounded by some habitat where, based on the GPAS modeling system, we shouldn't focus. The key thing here, the takeaway on this is grouse responded after the first year of treatment. So we treated it, it was treated, basically forest was harvested in 2016. On 2017, we got grouse response in those areas, and in 18 and 19, it continues to grow. So if we target these areas, we know where the source populations are and where the risk of West Nile virus is low, we will see positive grouse results. One of the key differences here with this sighting tool, it basically is just a model to show us where we should focus our efforts. It does not provide us with any kind of management actions that we should seek. The good part about this is it is a part of the COA tool, so you can click that onto that layer when you're looking at the COA tool, and grouse should pop up, and you should get some management actions that could be beneficial. Other multi-state rough grouse restoration initiatives. Again, the Game Commission is working with, I think, 22 other states looking into this similar situation and how best to address it. We are focusing partner efforts in high priority areas, and we're doing a lot of public outreach and with private landowners through this, trying to get interest through the grouse. Again, this isn't specific to pollinators, but as I went over previously, forests actually are pretty important for pollinators, and creating a well-balanced mixed landscape of forest age classes is going to be important for all wildlife. So again, you can find this tool at the PGC website, or you can just use the Conservation Opportunity Area tool to focus on it. There's a lot of background information and research that went into this sighting tool, and I will actually defer to Lisa Williams. She is a grouse biologist, and I can certify that she will be more than willing to talk to anybody about grouse and what we can do for grouse. So those are the major tools that we've been developed over the last 2 years, and that kind of ends my presentation. So if you have questions, feel free to throw them in the chat box, and I'll do my best to answer them.
Thank you, John, for your presentation on native trees and conservation tools. I do just want to remind everybody again, please mute your mics. We are still getting a little bit of background noise. And then that moves us forward to our final presenter this morning. Kathy Patnode, fish and wildlife biologist with the U.S. Fish and Wildlife Service. Kathy has been the environmental toxicologist for the PA Field Office of the U.S. Fish and Wildlife Service for more than 20 years. She has her Bachelor and Master of Science degrees in wildlife ecology and her PhD in toxicology. In her Fish and Wildlife Service position, She applies her knowledge of risk to plants and animals from chemical, physical, and biological stresses to ensure that habitats and their biota are protected. Her work on restoring high-risk sites has led to the development of her expertise in aquatic and terrestrial habitat restoration, including habitats to benefit pollinators. Her work with NRCS has focused on providing guidance on habitat protection and enhancement for Pennsylvania at-risk pollinator species. Kathy, I will go ahead and turn it over to you.
Thanks, Holly. Can you see my slides?
I can see them.
Great, thanks. So thank you everyone for joining. I'm going to give you a bit more detail about the list of species that Jim mentioned in the first presentation. Basically, going through how we came up with the list of at-risk pollinators that he has carried forward and put into play at the county-based level. This is the work of folks in our office in State College in conjunction with Jim's office at NRCS. So when we decided that we wanted to look at-risk pollinators, we looked at what we consider and identifying what those are. I mean, in 2017, our agency made a major move forward in listing the rusty patch bumblebee to the federally endangered species list. And it sort of highlighted for our agency that there was a lot of work that could be done for pollinators in general that might benefit other species and prevent us from having to take them to the endangered species list. So we looked at the status at the federal level. Was it something that we were considering listing? Had we been petitioned to list it because it was becoming so rare? We also worked with our the Pennsylvania agencies on what they considered the status of different pollinators and what their recommendations were. We also considered what's the best available science on these species and what are the prioritization considerations. And what we found when we went through the list of pollinator species was it sort of fell categories that we were calling conservation species and science species. The science species are, yes, we know this is a pollinator species. We don't really know much about its life history. We really couldn't make any recommendations for what land managers could do to benefit it because it was so poorly understood. And we realized that those are a category of species where we need more research before we can actually figure out what best management practices would even be. And the other group of species were what we were calling conservation species, where we knew a lot about the ecology. We knew about the life history. We knew what some of the obligate plant species were. We knew a lot about their reproductive cycle. And we actually knew maybe even a sketchy set of best management practices that we could start to consider implementation on the ground. So when we looked at the Pennsylvania's species of greatest conservation need, which others have referenced, we identified 3 species of bumblebees from that list, 2 of which we knew provided high pollination services. The third is pictured here is the Ashton's cuckoo, which is a parasitic nest parasite bumblebee, which, yes, it's a pollinator, but because it doesn't raise its own young, it doesn't provide a lot of pollination services. The list also contains 44 different butterflies and skippers. As you might imagine, that crosses a whole lot of different habitat types. But for those species, how much pollination benefit it provided was unknown, just because the ecology was not well understood. And then the biggest part of the list was made up of moths. Again, a lot of these fell into the science category in the sense that we really don't know enough about their life history to make management recommendations. narrowed it down to the list of species that Jim shared with you earlier. The goal with these species was to produce a fact sheet sort of document that could be used by biologists, and then a different form, a sort of condensed form that could be used to share with landowners that just gave them the basics. We decided early on to combine the rusty patch bumblebee and the yellow banded bumblebee because we were finding a lot of crossover with these two species as to habitat preferences, nectar species preferences, and pollen species preferences. And so we ended up bunching those two together. But otherwise, all the species here either have a fact sheet that is completed or is in the draft stage and should be ready for public use in the next month or so. And as you can see, we considered a lot of different factors, whether we had been petitioned to list the species, whether it was already endangered, whether we had it in review, whether our region had already identified it as an at-risk species, and then again, the Pennsylvania agency's determination of whether it was a species of greatest conservation need. So in each of these fact sheets that we developed, we tried to cover a lot of information, and I'll show you some examples of those. But it basically puts forward everything we know about the populations in the state of Pennsylvania, their life history, the different kinds of habitats they need throughout their life history. As Jim pointed out, they're not present in every county for some of these species, and so we put together a map of the priority counties, which Jim has now translated into the software that you can use. We have very detailed target plant lists for them, and then restoration approaches and maintenance recommendations for the habitats. Fall into the two categories. On the left is the field guide that we intended for professionals to make use of with a lot more detailed information. And then the right is just a scaled down version of that you could share with a landowner that has an interest in a pollinator species, or a landowner that you want to promote the benefits of a certain habitat restoration. And as I said, they're pretty similar. They cover all the same topics. They're just a version that you can share, and the literature is provided for you on the biologist fact sheet, but not on the landowner guidance. And as I said, these are some of the species, as Jim pointed out. Some like the yellow banded bumblebee and the regal fritillary, we think of them as meadow species. They're going to be well addressed by the NRCS pollinator mix that they have. Others are specialists, and part of why they are at risk is because the special requirements of their habitat are becoming scarcer and scarcer. And I say the frosted elfin, the columbine dusky wing, and the ostrich fern borer moth fall into those categories. Just run through, a detailed look at one of the field guides to give you a sense of how you could use it. As I said, they start out with, an explanation about the population. Why do we think it's at risk? What's been going on with it nationwide? What's been going on with it in Pennsylvania as far as population declines? Then it gets into the life history, and for some of these, especially the monarch, it's quite complicated because of its migratory behavior. But even with the other species, there are some complicated aspects to their life history that in some cases make them more vulnerable. We talk about the habitat in specific, the larval host plants and the nectar plants. And one thing I guess I would say is that if Jim pointed out, it's going to be hard to find some of the unique plants, either in seed or plant form, to help these species. But one thing that came out pretty clearly in putting together all of these is that for pollinators, we tend to be very focused on the nectar plant. And while that's really important, the pollinators seem to be far more flexible in what they will use for nectar as opposed to what they will use for pollen. And so if there's anything that you can do to enhance the basic pollinator mix when you're trying to help at-risk species and you can't find, individual plants, the seeds just aren't available, I would say that the one thing that you really can do is try and increase the amount of legumes, pea family native plants, like the lupines, the baptisia, the tick trefoils. Those plants are really important because they provide the pollen, the high protein pollen that seems to be sort of lacking in some of the commercially available pollinator mixes that focus on nectar. So this is an example. These are the two areas of the state that are delineated by the monarch efforts nationwide. And so there's primary focus in the western counties, secondary focus in the eastern counties in Pennsylvania. And as I said, we put together a very extensive list of the plant species that are used by monarchs and tried to give you some ideas about what season they're going to cover with their blooms and where in the state. Again, I think Jim has translated a lot of this information into the programming that NRCS has. And then we've given ideas about, how do you do the restoration if you're starting with a field, if you're starting with a pasture, if you're starting with something that already has a warm season grass planting. And we've done this, as I said, with all 9 species in 8 fact sheets. And I think that, we've tried to make it as user-friendly as possible, and given the landowner fact sheet being something that we feel like you could actually hand out and share. And that's all I have to provide.
Thank you, Kathy, and thank you to all of our presenters today. You all did a fantastic job. So we do have a couple minutes here at the end if anyone has questions. We do ask that you put them in the chat box due to the number of people on the call this morning. And if not, we do have the contact information for all the presenters. So after this training, please feel free to reach out to any of us. I'm just going to give it a couple minutes here and just see if we get any questions in the chat. Okay, we have a question. Will a recording or slide from the presentations be available to us in case we missed any website resources, etc.?
So I can address that. This is Peter Hoagland. Yeah, so the meeting is being recorded. It's going to be placed on the PACD Clean Water Academy training site, and for NRCS folks, we're going to make it available on an internal SharePoint site as well. So please look for those resources. It'll be a recorded meeting placed in those locations.
Okay, another question. What are suggestions for treating Japanese stiltgrass with recently planted pollinator mix restoration areas?
Polly, this is Kathy. We've had the best luck if the areas are small, actually hand pulling Japanese stiltgrass. If you can do it before it starts to set seed.
Okay, I don't see any more questions rolling in. But again, please reach out to any of the presenters if you have questions. Their contact information is there in the chat box. So we're going to end a couple minutes early today. And I just want to say again, thank you all for joining us today. We hope you enjoyed the training. Thank you to all of our partners and all of the presenters. And we hope that you have a wonderful rest of your day. Thank you so much.
Thanks.